show outside, so now it is a show inside. So it's always difficult to keep you awake because it's during the nap time, but we'll try to make sure you don't fall all asleep at least. Okay. Okay, so with the chief engineer, we'll give you all the information regarding the technical specification of this amazing vessel. Okay. Back. So the idea was raised in September 2015 from Ponant. The goal was very clear. It was to build a ship capable to bring passengers in the North Pole. Considering that we had no experience in icebreaker and in this kind of itinerary, Ponant went to see the specialist of the icebreaker design, Aker Arctic, which is based in Helsinki, Finland. They are the one who are design most of the icebreaker, either for Russia, Finland, Sweden, Canada. They study different statistics and analysis of the ice thickness, temperature, and so in the North Pole in the summertime, in order to decide that the ship has to be capable to yeah, bon, it's written here. Minus, the ship has to be capable to face a temperature minus 25 degrees, to pass to an average thickness of 2.5 meters, and to also pass a ridge, which is this, of 15 meters.
Wow.
Yes, so it was to start to build this ship. And here, you have some classification of what we call a polar class. Polar class vessel, it's a vessel which are here. This is a scale, or you have here the scale from 1 to 7. And according to the power of the vessel and the hull thickness, it gives you an idea what will be the average ice capability, ice-breaking capability of the vessel. So in the world, the most strongest icebreaker are PC-1, and the only PC-1 in the world is the Russian nuclear icebreaker, the one we saw, the 50 years of victory. There is no other PC-1 in the world than the Russian one. And you can see then Commandant-Charcot is PC2, Polar Class 2, is just under. This is the most powerful icebreaker, non-nuclear. Yes, classic propulsion. The Polarstern we saw is PC3, and most of the scientific or working icebreaker, either from Canada, US, or Finland, Sweden, and some other country, are PC3, 4, or 5. And there are very few passenger ships which are PC6 or 7. But PC6 or 7, the ice thickness is less than 1 meter, so definitely you cannot go to the North Pole. It's why you can see we have a very high scale with this vessel. If you compare with our other vessels from our company, Boreal, Austral, and so, they are not polar class, they are reinforced to sail into the ice, but you can see there is a big gap between, okay? So they can sail with some open water and drifting ice, but they are not icebreaker, definitely. So what makes the difference to be a polar class. First is the thickness of the hull. The bow here, you have 6 centimeters of steel, really in the bow, okay? And the what we call the ice belt all around the vessel is 4.5 centimeters thick, the hull. A normal ship like Boreal Austral, it's 1 centimeter. And also the frame, which is holding the vessel, the structure, the space between the frame, it's only 40 centimeters here. So it's it's a very kind of solid structure. A normal vessel will be a bit more than 2 meters distance between each frame. Okay, here's one point. And second point is the power of the vessel. Here the vessel is fitted, and you will see later, with 2 propulsion engine of 17 megawatt. The 50 years of victory, I think she's in megawatt, I don't know, I know in horsepower. 3 times 18, okay. So definitely she is like she has one more engine. In fact, she has 3 shafts, and we have only 2 propeller. And if you compare to the power of the other vessel of our fleet, I mean, the Commandant-Charcot, it's 7 times more powerful than Boreal and Austral. Okay, yeah. So I mean, you need a lot of power when you sail into the ice. So this is what the definition of polar class is: the structure of the hull and the power of the engine. And so Akai Arctic designed this kind of ship, and they made a model in order to test it in a pool to check if it's efficient, yes or no. The specification of this vessel, it's as you can see, the hull is in the shape of a banana, because the main way to break the ice is going forward, and it's the weight of the vessel which is climbing on the ice which is breaking the ice. Okay, she's not cutting the ice, she's breaking by the weight. Okay, so she's climbing on the ice, but if for any reason the ice is too strong and we cannot succeed to pass through forward, in this case we can do backward. It's why it's banana shape on the back as well. And I will show you, we reverse the rotation of the azipod, put the propeller facing forward, astern, and the propeller will drill a hole into the ice. And well, in addition, there is some stabilizer which are not in this model, and there is some bow thruster as well, which are not in this model, but it gives you an idea. And those what we call skeg are just to have a better flow of the water and the ice when they are going into the propeller. So this is the main drawing of the vessel. So you can always see the banana shape, the azipod in the back, the bow thruster. And in this design, what is important to see, it's this vessel is dual combustible engine, which means the engine can work either with a diesel or LNG. And it's why we have 2 huge tanks of LNG, and you will see later on we have some picture. So it takes a lot of space. And the engine, we have 2 independent engine compartments, where here you have a really vertical zone which separates these 2 engines. So in case you have a fire flooding in one of the compartments, the ship can still sail safely with the other engine compartment. Everything is totally independent regarding cabling, the supply of the energy, gas or diesel, and so and so. Regarding the characteristic, so it's why we say dual fuel engine. We say it's a polar class vessel too. What is important, it's a clean ship. She has a clean ship certificate in order to, which has been delivered by the Classification Society of Bureau Veritas. It's to make sure this vessel is clean regarding the environment. I mean, there is some regulation to make sure all the exhaust gas we are complying with all the most recent regulation to make sure there is less emission about this vessel. Also, comfort, noise, and vibration. So this is the highest level to make sure there is less noise and vibration on board. You have to know that when the ship has been built, all the structure, the ceiling, there is some kind of they are fixed on the caoutchouc rubber to make sure they limit the vibration, the transmission of the vibration everywhere. So all the bulkhead, the ceiling, even the floor, there is. This is my wife. Sorry. Yes, Captain. Ouais. Ouais, j'ai vu. Oui, merci. Merci. Oui, ok. Ok, super, merci. Merci. Okay, everything is okay at home. So, yes, I mean, also all the floor, there's a lot of additional resin or cement to make sure there is no transmission of the vibration to the vessel on the floor. And this vessel is as well hybrid electric. This is the first vessel in the world to have three types of energy: diesel, LNG, and electric hybrid. I mean, there are some passenger ships already with LNG and diesel. There are some passenger ships with diesel and batteries, but there was no passenger ship when this ship has been built with the combination of the three energy. So definitely it's a new, it's a total prototype. So the length is a little bit less than 150 meters, just to avoid to have, because the regulation, when you are 150 or more, you have to have a pilot in the Svalbard and in the Greenland, but for 199.9, you don't need a pilot. So the wide 28, the draft 10 meters, the average weight displacement is almost 30,000 tons, and the maximum capacity is 460, which can spread between more or less 200 crew and a bit less than 250 guests, in fact. And this is the technical information. We have two azipods, we'll come back later on. Two bar thrusters, batteries as well. And we have 6 diesel generators, which has been built by Wärtsilä. And yeah, you can see when they start to build the ship in December 2018, and she has been delivered in July 2021. Normally, she was supposed to be delivered in March 2021, but due to the COVID, it was difficult to get some furniture on time, so the delivery will be postponed. So this is more or less. So now, to build and design the ship, there was some criteria. Maybe you can speak about LNG. You want to speak about that, Chief? To minimize our impact on the environment, the company chose the LNG as a fuel.
LNG was chosen for the limitation of emission in the exhaust gas, so at this time it was the most environmental friendly fuel, so that's why it was chosen for this vessel. This dual fuel engine are the last generation because they are designed specially for gas. It's the first type of engine initially designed for gas and not diesel engine adapted to gas. The hybrid electric, we spoke about it. It's we have 2 packs of batteries that are able to supply the ship for all the electricity consumed on board, but also for additional propulsion power.
Yeah.
Especially useful in the ice.
Yes, just for your information, the way we are driving the ship presently in the ice, all the our way to go in and come back from the North Pole, we were using only 2 generators, 2 engines, because we didn't need all the power instead of 6. But we use the batteries as an additional generator, which means when we can see that the ice forward is a bit more thick or hard, we use the energy from the battery, and when we are in open water, we reduce the power and we recharge the battery. So the battery are used when we need additional power to go into the ice, and when we have open water, we recharge the battery. So in fact, we save the fact that we don't need to start a 3rd generator. So we save kind of power.
Also, so the garbage and sewage, we have also big equipment in order to treat all our sewage water and to be able to reuse part of the water for technical use only, not for drinking. And it's perfectly clean water that we reject to the sea. The garbage as well. We store everything on board. We have a lot of compactors, shredders, so as to reduce the volume and to be able to store until the next shore facility.
Where do you get your sweet water from? You bring the sweet water, or you have a?
We offload the garbage in Longyearbyen.
Out.
Yeah.
Where you get your sweet water, you put it in tanks when you start. You don't convert salt water into sweet water.
We convert salt water from fresh water. All the fresh water you have on board are produced from seawater with a reverse osmosis system, and it's why it's written here the elimination of plastic bottle, because the water you are drinking is the water from the ocean. We just remove the salt after we remove the chlorination. There's a special treatment to make sure she is testy.
To remineralize, to put minerals in the water, so it's suitable for drinking. And then after the water is retreated and sent back to the seawater. It's a complete cycle.
And it's why all the water which it products, we we fill up the glass bottle you saw in your cabin. So we are cleaning this glass bottle, and there is no elimination of garbage.
Some of your guests do have to have bad feeling if we use a lot of water when taking the shower, and because using up scarce water, or if it's something, if you have a cycle, that it's not so bad.
Yeah, it's a cycle. The ice routing, I will speak about that later on, and the under-radiated noise. I mean, this is the first icebreaker which has been built with 5 blades on the propeller instead of 4 normally. The purpose was to reduce the noise under the water, okay, or the radiation, yes, and to be more efficient. Second criteria was also to comply with some safety, reliability. Of course, the performance of the vessel and air maneuverability in the ice was very important. As you can see, this ship is extremely maneuverable. I mean, we can really slalom very easily due to the fact that she's fitted with Azipod. We had to comply with what we call the Polar Code, and when you carry some passenger in polar area, you have to make sure all the safety equipment you have on board are capable to maintain everybody alive during 5 days in total autonomy in case we lost the ship due to the fire or if it's going aground or whatever. So we had to develop some new equipment, and you saw some of those equipment when we were in the North Pole. We did a demo, and I will give you more detail about that. So we spoke about the batteries, of course, safe return to port. This is a new regulation. It's why the engine compartment is separated in 2 independent engine compartments. In case one is totally out or over due to the fire or whatever, we can still bring back the ship back to the port. And this is the only passenger ship in the world due to the fact that she has been built during the COVID period. This vessel is fitted with medical oxygen generator, so we can produce oxygen for medical purpose without any limitation. The next criteria was the science. So it was clear since the beginning. We didn't want to build only a passenger ship to go to the North Pole, but also a ship dedicated to the science. That's why you were able to see there is some lab on board, wet, dry lab, but some additional equipment you will see later on, in order to welcome some science mission on board that we have during this cruise. So it's a vessel, what we call of opportunity for the science. And the comfort, of course. I don't want to deny our friend from 50 years of victory, but this is not the same comfort. Okay. So definitely, I mean, this is the only ship in the world can offer such comfort in such extreme remote area for this kind of navigation. Also, it was important to take care of the crew accommodation. Initially, the crew cabin were on deck 3, and it has been decided to put it on deck 4 in order to make sure they won't suffer too much from the noise when we are in the ice as well. So to improve the crew comfort was important. And it's why there was a lot of innovation regarding the LNG tanks. We'll come back later. The dual fuel energy engine. This is the first time this kind of engine were installed or fitted in the ship. the batteries as well, ice sweating, all these are totally new with this kind of vessel. So here, this is the most artistic place on board the vessel, and this is the interior of the LNG tanks.
Yes, unfortunately, it is something nobody can see because it's full of liquid methane. These tanks are designed with several layers, with thermal insulation, secondary barrier which is made with resin and aluminium, and another layer of insulation, and then this last coat that we call the primary membrane, which is made by special stainless steel. And the problem with liquid LNG is that the temperature is minus 160 degrees. So regular steel will not support this temperature. It will break. That's why we contain this very cold liquid in a specific tank with a specific stainless steel material. For safety reasons, these tanks also are specially designed to reach a pressure of 2 bar. On regular LNG carrier, for example, it's less than 1 bar, it's 800 millibar. And so this improvement allows us to be more safe and to avoid any problem of pressure inside the tanks. The big advantage of the LNG, I told you it was the emission that are much voilà.
Why we use LNG?
Why we use LNG? So this is a comparison between LNG and marine gas oil and heavy fuel oil. So the heavy fuel oil is the reference with the 100%, and so we can see that regarding the sulfur, the LNG is minus 99%. For the particle, also the same, and also for the NOx. And so we are complying with all the more strict regulation with by using this fuel. This Wärtsilä diesel engine are the last generation with a very good efficiency and specially designed for gas. Yeah, so maybe it's a little bit optimistic, but yes, there is less CO2 emitted with LNG as fuel.
Yeah, and
so this is where some study to be even better and to find another source of LNG with biogas, which is a lot developed now. And synthetic methane, a little bit more further in time.
Yeah, the last bunkering of LNG, which has been done in Reykjavik, there was already a percentage of biogas inside. So it's a combination of natural gas and biogas. So this is a battery. So we have 2 packs of batteries. This is what we see. All these batteries are enclosed in separate cabinets. This is also for safety reasons. If we have any trouble on one pack of batteries, the rest is not affected.
This battery has a very big power because they have 4.5 megawatt, and as we said, it's they can supply as much power as one diesel generator. And the big advantage is it's immediately available. We don't lose time for starting a standby generator and synchronizing, coupling, and so on. So this is what we call the spinning reserve. The peak shaving is also to be able to maintain a good load on the diesel generator and to have them with a big, good efficiency.
Just want to highlight then now when we go in some port, like for example in Reykjavik, we have to complete what we call index performance indicators. All the cruise ship has to do that. It's the emission they will provide when they are in a call in a port. And due to the fact that the Commandant-Charcot is using LNG and the batteries during this season 2023, we were much over any ship in terms of rating. We had 86%. It was a very high rate. Compared to the other ship, they were 20%. So it gives you an idea. So it's why this ship, with this technology, it's considering the cleanest on the market. Because when we are in the port,
we can stay 1 or 2 hours running only on batteries with no diesel generator running.
Yeah.
So we'll restart diesel generator after with a good efficiency to reload the batteries, and we are back for 2 hours free of emission.
Yeah, we can do 1 hour on battery, 1 hour on generator, 1 hour on battery, 1 hour on generator, instead to have all the coal on the generator with a low efficient rate of 30%. So it's much convenient for the environment. Regarding the ice routing, it's exactly what we did. So I give you, we developed for this vessel ice routing software, and I will explain you how it's works. Of course, you have to download some ice data. For example, on this map, you can see there's a line more or less here, and all this type of ice is exactly what I explained you at the beginning of the cruise. This is what we call multi-year ice, so it's old ice, more thick and much more difficult. This inside this kind of Christmas tree, it was considering as first year ice, all this inside, so it's more soft and less, the thickness is less important. And so when we enter the port from where we live and where we want to go, and the software will submit to you a route to go this way. It's why we went first around Svalbard to the north and then the northeast before we go north after, because the ice condition is favorable in this area and not if we go straight to the north. Okay, and we have the ice measurement system on the bow you were able to see, which is deployed and give us the information in real time in the bridge as well. And all this ice information thickness are recorded, and they will be shared with some institute in Germany which is studying the ice condition in the Arctic. So this is the what we call the Azipod. So this vessel is not fitted with what we call a a shaft with a propeller and a rudder. There is no more shaft, propeller, and rudder. There is this azipod, so it's a kind of superstructure which is suspended on the stern of the vessel, where inside you have the electric engine, and this is turning 360 degrees.